Hello, everyone. You guys want to hear me talking, or you want to keep talking between each other? It works both ways for me. I'm more than happy to hear what you have to say, but they gave me like 30 minutes to tell you about the project that I've been working on recently. So, hello, everyone. I'm Milen Dyankov. I work for a company called LifeRay. My position there is developer advocate, which means I mostly go talk to people like you. And by talk to people like you, I mean talk both ways, like tell you what we do, and we're really interested to hear what you guys do. Anyone here heard of LifeRay? Okay, half there, not bad. So I'm not going to talk about LifeRay today, though. Just starting by showing you a few of the things that have changed at LifeRay recently, and by recently I mean the last couple of years. You may recall LifeRay as a company that used to provide a portal solutions, and that's still the case. We still work on those things. What happens though is we are trying today to split those into more like precisely focused technologies that attack particular problems that people, and particularly developers, needs to solve. So as you've seen, like maybe recently, we evolved into like building all kinds of different things, like all front-end frameworks, and splitting the platform into small pieces. Now, one thing that you come to realize when you try to get this huge Java project and split it into like tiny little pieces is the dependency hell. And then you all of a sudden realize, well, we can't really easily do this because this part depends on that part and so forth. So one thing that we've done is we moved to use OSGI as a core framework and actually like in a process of trying to establish the module boundaries. So, okay, this thing has its own responsibility, it doesn't really interact with that other thing. And so I'm going to rush through the slides so I have more time for the demo. But basically, dependencies is what I'm going to be talking about today. And this is kind of a lesson learned, and this is what made me work on the thing that I'm going to be showing you later on. So the first thing first, remember the times when we used to use the new keyword? Someone still using it? Okay, I figured so. That's because at some point in time, we had this thing Spring that showed up and told us we should actually use XML for that. And we started typing beans and building this nice and beautiful XML files. How many of you love to write those? Hey, here you go. You're my hero for today. Well, okay, but not a lot of people, as you see, you're the only person in the room, so we ended up today doing this at component, at whatever, like annotations all over the place. That's why this happened, though, if you think about it. It wasn't just a new design paradigm. It wasn't just let's just change the way we do things, right? What happened is, it's actually changed the way we think about software. A whole lot of new things showed up, like you can all of a sudden do interceptors or declare transactions and stuff like that that you couldn't do before. It wasn't just, oh, let's do stuff differently, right? But let's talk about dependencies now. Remember the times when we used to have libs and deps or deps folders, and then you had to deliver like one application, and there was like this huge list of jar files in your file system and so forth. Okay, those days are gone because we have now Maven, right? How many of you use Maven? And that's what I figured, like pretty much everyone. Even if you use Gradle, you use Maven. I mean, in terms of Maven Central, right? So that's the ultimate truth of like where all the libraries are. Well, but if you think about it, it didn't fundamentally change the way we think about dependencies. Well, it did change the way we store them. We don't have to keep them all in the project folder, in the lib, or whatever, right? It's just a central place where we're just going to go grab them by some kind of ID. But how do we use them? It's essentially the same thing. You just say, I need this artifact, and that's it. I need this jar file. Okay, and so we still have this beautiful thing when we build applications. So what I find to be wrong with Maven is essentially those, well, it's not Maven, but Maven Central in general, not the build tool, but like the way we manage dependencies, is that it's still manual work. It's like dependencies can be transitive, but at the end of the day, if there is any conflict, you, the developer, need to figure it out. The tool is not going to help you in any particular way. You have to say which version goes to production. How many of you are aware of the fact that there are version ranges in Maven? Hey, look around. That's a beautiful feature of Maven, and every time I ask this question, that's about like 5 or 10% of the room that even know that you can do version ranges in Maven. But this doesn't really help a lot. You can say my tool works from version 2 to version 3, but at the end of the day, if there is conflict, again, it's you. You need to solve it. Scopes are the same thing. You can say, this SLF4J, for example, is provided by my runtime. But how do you know? How do you know someone didn't change your runtime meanwhile? Right? There's no way for Maven to go and check what is actually at your runtime. This is your knowledge. You telling Maven, I know that on my runtime this is this jar file. So it's again you. And then there is like dependency between jar files. So this jar file depends on that jar file. What about resources? What about operating systems? What about other things? Like in the IoT world, you would be depending on a hell lot of other things than just jar files. And there's no way for Maven to actually describe those dependencies for you. So it fundamentally goes down to one thing. Dependency management in Maven or any other tool that I'm aware of fundamentally does not tell you anything about why this dependency is there. It tells you A depends on B, but it doesn't tell you why. And so this is how we think about dependencies. We have box, and that box contains something, and then there's another box containing something, and we just say, well, box A depends on box B, and go figure why, right? And then in the real world, that's not like this. In the real world, there's something in that box A that needs something in that box B, and that is why we say box A depends on box B, but we are totally losing this information about what exactly is causing this dependency. And that is why later on we have problem with resolving, because we don't know. Okay? So let's try to figure a different way to express those things. So what if we have this magical thing that's going to look inside that box and then put a meta information somewhere in the artifact while saying, you know what, this box needs XYZ, whatever that is. And then the same thing can look in another box and can say, well, guess what? This box has XYZ, right? Now, if you happen to have this information, not only A depends on B, but A depends on B, like something in A is needed and something B provides, then you don't need to have dependencies anymore. You can just have contracts. And this is how the real world operates, right? You don't depend on your service provider. You depend on the service that it provides. If you're not happy with your service provider, you can change it and get the same service from someone else. It is the service, it's not the provider that's important for you. It is what's in the box, not the box, that's important for you. Okay, so this was like the motivation to start working on this project, which I'm going to demoing now with this fantastic Java contracts demo, which you can find online and play with it if you want to. So let me go quickly show you what is it all about. Okay, how do I need to stop this, I guess. Okay, so here we have a simple, very, very simple project. It has an API, and this API has a simple interface. It's a calculator. You guys can read this? You don't have to read the exact code. It's just so that you get the idea. So it has a calculator. It's a simple interface. You pass a string, which is a mathematical expression, and it calculates the result. That's it. And then you have this thing called simple calculator, which is the implementation of that interface, and basically does some stupid thing like parses it as a regular expression, and if there is a plus, it adds, and if it's a minus, it just it does these two operations and nothing more than that. Okay. So that's basically it. And then we have this thing called markup. And markup is a very stupid markup language which understands the math tag. And anything that it finds in between a math tags, it treats as a mathematical expression. So it parses a text. If it sees a math tag, it's just going to calculate and print out the result. As you see, it's very simple, very stupid, regular expression thing. And so finally, we have this thing called editor. An editor is nothing more than a Java swing application. It just shows a window. You can type something, and if it figures the math tag, it's going to calculate stuff for you. So this is basically how it works. Now let's look at the dependency. Obviously, API, well, wait a second, because this is wrong. Yeah, because I'm at the wrong place in the branch. Okay, so we should be here. Okay, so this is like nothing. It has no dependency apart. It has a parent file, so I can build the whole thing together. The simple implementation, it only depends on the API, which is obvious. Then you have the markup thing, which only depends on the API, which is kind of obvious. And then you have the editor, which only depends on markup, because that's the only thing it needs, right? And all this thing here is Maven Shade plugin, so I can create a single executable jar file to show you how that works. So let me go and build that thing. Here's the project. And I'm just going to build it. It's going to take a second. OK, now we have all the modules ready, and I go, OK, so first of all, let me go back to slides for a second. And this is how it looks like. So just you get the visual, right? So we have the calculator API, the simple calculator implementation, markup, editor, and then we build a final application. It's all clear, right? It's plain, simple, stupid application. OK? And now let me build that for you. Let me run it for you. So I'm just going to go to my editor target, and I'm just going to say Java jar editor jar. Boom. And it shows up something like this. So here is something that I have math in it. And if I click this button, it's going to convert this into whatever the mathematical expression results in, right? Boom. Anyone willing to take a guess why it didn't work?
Because you didn't use the implementation. You are only requiring the API, not the implementation. You need an implementation.
I'm now figuring which. Yeah, this is the one. Yeah, that's the thing. Because our editor has no idea of the implementation. So how do we solve that? I need to do this, right? How many of you would solve it this way? Yeah, a few people. It makes sense. Then make sure you don't invite any famous Java architectural personnel in your work, because they're going to tell you this. Then having API makes absolutely no sense. And they will be right in this particular case. Why would you do API if your whatever uses your API depends straight on your implementation? Okay, so that's not really the best way to fix it. How do you fix it? Maybe this way. How many of you would fix it this way? Yeah, that would fix the thing. Well, we have editor, it needs markup, and it needs implementation of the calculator, so it seems reasonable. Okay, but then you extend your editor with another editor extension that does some calculation, and then it depends on another calculator. Welcome to the jar hell. Now, this is a very simple application. Scale that to a banking, whatever, 100,000 jar files, runtime environment, and you get the picture, right? You're spending days trying to figure out what's, where, and why. Okay, so how about doing something else? How about introducing a contract between markup and a simple calculator? And let me show you how you can do that with this little thing called EM. It's a project that I created. It's like something that I'm just currently working on just for demo purposes. Eventually, it may end up being a real production-ready thing. So here we go, and I'm gonna go first to my Git, and here we go. And then I'm just gonna show you how that works. And Git, where it is. Okay, here we go. So you see the changes and the code, and don't bother you with the rest. Okay, so the only thing that changes here is my POM file. And in that POM file of mine, the only thing I've added, I added two things. I added a Maven extension, and that's the extension that I told you I'm working on. It's called EM. It's abbreviation from eccentric modularity. Basically, I added a dependency on an annotation, a package that contains only annotations that I'm going to be using to define a little bit of things here. Okay, so what else I can do is I can convert now my projects to real modules. And this is nothing to do with Java 9 JPMS modules. It's just the idea of modules. Yes, you've guessed right. It comes from the OSGI world, but you're not going to see me using anything OSGI specific in this demo. It's just so that you know where it comes from. So what I'm going to do now is I'm going to change my modules to tell the extension that are real modules. And the only thing I do is I do this. I basically say, well, this is a module, and then this is the API module, and then this is my implementation module, and so forth. You see the POM files, it's just this. Nothing else changes. Well, now I'll go to my simple calculator, and I say, I want to add this annotation. And I'll say it provides a functionality. And I call this functionality a fantastic calculator. And it doesn't really matter what I call it, it's just a name. I provide a functionality and by this method. And then I'm also going to go to my markup method, and I say, well, this requires a fantastic calculator. And that's pretty much it. I'm basically defining here my modules and metadata information about what is inside, what do they provide, and what do they need. Okay? So what I do next is I'm just going to go, and now in my editor, I'm going to change my POM file. And I'm just going to say, well, resolve that for me. You know there is someone that needs something, and you know that there is someone that provides something, so please be kind and resolve that dependency for me. And in here, I'm just going to provide a list of possible solutions. And this is where people get confused. This is not a dependency. It's just a list of the possible so-called contractors that can fulfill that contract. Think about it this way. If you want to fix your car, and you don't know who can fix your car, what do? You don't get the phone book and count every single number in the phone book. Can you fix my car? No, thank you. Can you fix my car? No, thank you. You don't do that. You get a list of companies or people who potentially know how to fix your car, and you call each of them and try to figure out, can they do that, when they can do it, how much it's going to cost you, and stuff like that. And this is what this is. It's just shortening the list so you don't have to scan the whole Maven Central about potentially stuff that will work for you. Okay? And this is why we have a contractors list in here. That's pretty much it. And now, let's build the whole thing again. Wrong folder. Hey. All right. it's gonna try to resolve this stuff for us. And then we're just gonna go to the editor again, to the target folder, and run Java jar editor again. And this is the same application, and if I click a preview now, it works. I didn't have to add any other dependency to my any of my modules. Basically, what I did was this. I said at the markup level that I require an implementation of a calculator. And on a simple calculator, I said I provide an implementation of a calculator. And then I have this resolver at the editor which says, well, figure it out. Find me something that fulfills my requirements and establish a contract between the two. This is basically how it works. Now, to just show you how this can go one step further, let me see if I didn't miss anything. Of course I did. So if I later on, just to continue on the example, if I later on provide another implementation of the calculator, nothing changes, basically. Resolver just has more options, and it will figure out one or the other. Okay?
How does your module figure which one is the right one?
You one step ahead of me.
Sorry.
All right. So let's do one final thing here. We'll introduce another version of the calculator by doing this. Where is diff tool? Here it goes. Okay, so this is another version of a calculator, and this is a little bit different. It has a little bit more information in it, in that we also provide options in here. And we just say, well, guess what? This is also a fantastic calculator, but it also can add and subtract and multiply and divide and do the power off and all those things. Again, those are just metadata information. We're not just saying now what service is provided, but also what options it has. Okay, and then I'm going to do one more thing. I'm just going to create a RESTful service here real quick, and that's the final part of the demo. Where it is? Here we go. And now, if I do the same thing again here, okay, so here is my RESTful service. So my RESTful service is basically using annotations to define what it depends on. Now, it uses a framework that's similar to Spring, but it comes from the OSGI world. It's called declarative services, but you can think of add component as being a Spring bean, basically. And it says it requires JAX-RS server. And that's an annotation that comes from the YAM extension. Basically says, well, for this thing to run, it needs a JAX-RS server. I don't care which one. And it also requires a power calculator, whatever that is. And the rest is just standard JAX-RS annotations. Okay? So if you look into what actually this other annotation is, requires power calculator, it's defined in this way. It says it requires a fantastic calculator, but using the filter, it has to have power equals true. So not just any of the implementation, but those that also have power equals 2. And obviously, you can define many more filters in here and narrow to what to choose from the list of the options that you have. Now, one other thing that I have in here is the POM file, which is important for you. And in here, I have profiles. So here's my developer profile. And this is the list of contractors to choose from when you do when you are developing time. This is my standalone, and standalone is just like when I'm gonna run to production. And I also have another profile which says life rate, which is in the case where I want to deploy this to an existing environment, which I'm gonna demo to you in a second. Now, one thing to also notice is I can actually provide additional contracts in my POM file. So for my development environment, I would say, well, guess what? I also want to have a local console and a web console. And I don't want that for my production environment, nor I want that for my liferay environment. Okay, so how that works? Let's go and build a thing. And it's going to build like the two more modules now, the fancy calculator and the RESTful service one. And this is by default building my developer profile. So when I go to my REST target and I do Java jar, REST jar, this is going to simply start. And because I said I want to have a local console, here it is. I have it. I can do bundles list, and I can see what modules run inside my application. I can go now to my web browser and call this RESTful service. Let's see if we can do powers, actually, 2 to the power of 8. Here we go. It's like beautiful RESTful service. But I can also do things like system console bundles, and I can actually have a administration console for on the web for my web application to see what is inside. That's, of course, only my development environment. So, because I'm running on time, I'm not going to show you the production. I'm just going to show you the other liferay one. So in here, I'm just going to do the same thing, Maven clean package, but with my profile of liferay. I'm building the exact same thing, no code changes, just with different profile. And so, as you can see in here, it contacts my environment and tries to figure out what is already in my environment and resolve against the stuff that's already there. I don't have to tell it. It's going to go and check it and figure it out on its own. And when it does this, it's going to create an export folder in here and tell me, well, guess what? In order for you to run this stuff in your environment, those are the jar files that you need. And now, if I go to my liferay environment, which is in here, OSGI modules, let me first prove it to you that it's not there. So if I do localhost 9090, which is my liferay /o/services calc, it doesn't work because nothing works, nothing is installed there. So I'm just going to go copy all those jar files there. And I need to wait for a second to these to be deployed. And I think it's already there. So I can now do the same thing again. I can go to my liferay environment, and I have the exact same thing running inside my liferay environment. And hey, it has the ability to do 2 to the power of 8, I hope. Here it is. So this was the exact same application. I didn't have to change anything. I just changed the way the resolve process works. Okay, so if you want to play with that extension and how to install it and use it in Maven, that's the homepage of the eccentric modularity module, like Maven extension. How does it work is basically this. So you have some jar files in Maven Central. And those jar files provide, like obviously none of the existing jar files provide this information, but there's a way to enhance them with that information. But the point is, if we start putting metadata information in the jar files and putting them in the Maven Central, we have a list of modules, real modules that tells you, I need this, I provide this. And then the extension, what it does, it gives you the option to keep local configuration of contractors, so you don't have to go to Maven Central, but that's kind of an optional thing. So then when you build a module, when you say, I require something, and I have a list of contractors, and this list of contractors currently is only local, like the way you saw me defining it in Maven POM file, but it is the same way it can come from a remote service somewhere. it goes against that list and resolves what actually your application needs. And then it builds a runtime. Or it builds a list of modules that you deploy on an existing runtime by contacting the existing runtime and figuring out what is already there. That's pretty much it. I'm out of time, so I'm happily answering questions outside if you have such. Thank you very much.